I'm Rajesh Uppal, Director IDST. We bring sharp insights and foresight on defense, security, and emerging tech. Let's dive in.
Imagine a computer so powerful it could simulate molecules for new medicines, optimize entire airline fleets in seconds, or break encryption methods that protect today's internet. That's the promise of quantum computing. And while fully fault-tolerant quantum machines with millions of qubits are still years away, 2025 is shaping up as a turning point, a year where breakthroughs, benchmarks, and strategic imperatives are redefining the landscape. Now, you might have heard the term quantum supremacy. That's when a quantum machine does something a classical computer simply can't. Google's Sycamore achieved this back in 2019. But supremacy alone doesn't equal practical value. The real milestone is quantum advantage, when quantum systems start solving real-world problems better, faster, and more efficiently than classical ones. And in 2025, we're closer than ever. But here's the challenge. How do we measure that advantage? For years, progress was judged by qubit count. The more qubits, the better. But quantum bits are fragile. They lose information through noise and error, making raw numbers misleading. That's why researchers are pushing for smarter benchmarks. IBM introduced quantum volume, which looks at qubits, stability, and error rates all together. DARPA has gone even further with its quantum benchmarking initiative, evaluating technologies from over 15 companies. And the focus now is on logical qubits, error-corrected qubits stable enough to be trusted in real-world applications. This year, several breakthroughs stand out. Microsoft's Majorna 1 processor, based on exotic topological qubits, promises far greater stability. IBM's Quantum System 2, with a 156-qubit modular design, is 50 times faster than earlier generations. And D-Wave's Advantage 2 processor, with over 4,400 qubits, is already solving optimization problems 25,000 times faster than classical systems. Together, these advances are pushing us beyond experiments into practical impact. And here's a key trend. Hybrid computing frameworks. Think of it like teamwork. Classical supercomputers handle what they're best at, crunching data, running AI, and managing logistics. Quantum processors then step in for the hardest parts, simulating molecules, cracking optimization puzzles, or securing communication. Airbus, for example, is using Microsoft's Quantum Ready program to model sustainable aviation fuels, while Volkswagen is tapping D-Wave for real-time traffic routing to cut fuel cost. It's not quantum versus classical. It's quantum plus classical, working together. Beyond computing, quantum technologies are already making an impact. Quantum random number generators are securing financial data and even powering online gaming fairness. Quantum key distribution is enabling ultra-secure communication tested by banks, telecom operators, and defense networks. In healthcare and navigation, quantum sensors are detecting magnetic fields, mapping underground structures, and even helping in search and rescue operations through advanced imaging. And the race is global. The U.S. is investing billions through DARPA and the National Quantum Initiative. China is embedding quantum into its defense platforms. Europe is building continent-wide infrastructure through the Quantum Flagship. Japan and South Korea are partnering with firms like IonQ and ID Quantique to develop secure communication networks. Even the United Nations has declared 2025 the International Year of Quantum Science and Technology, highlighting just how strategic this field has become. But there's still a long road ahead. Error correction is the biggest hurdle, and new architectures like Google's Willow chip and IBM's Flamingo code are making progress. Companies like Intel are betting on silicon spin qubits for scalable, manufacturable designs. and startups are racing to prove that quantum isn't just a research project, but a commercial reality. So where does this leave us? 2025 isn't the year of universal quantum computers, but it is the year of quantum readiness. Enterprises are piloting hybrid frameworks, governments are building quantum-safe infrastructure, and researchers are setting benchmarks that matter, ensuring quantum systems are measured by the problems they solve, not just the qubits they count. Quantum technology is no longer just theory. It's starting to deliver real-world value, and the choices made now in research, investment, and policy will decide who leads in the next great technological revolution. Thanks for watching. Subscribe, follow, or visit idsth.com for more cutting-edge defense and tech insights. See you in the next one.